Oh no, what in tarnation happened here? Oh, I lost my document. Oh, that can't be too good. Welcome everyone to the Intel F00F Bug. Now, it's not the screensaver you're seeing, but it will help to mystify your mind while discussing this bug. So I had a comment on one of my TikTok videos involving a different Intel bug that Intel is apparently back in hot water again with some more CPU troubles. And in fact, when I look online, I come across various articles talking about that and Intel having problems once again. So I figured, hey, why not just go back and look at the Intel F00F bug from the 90s involving the first generation Pentium processors. So to understand what's going on here, we need to look at Intel's x86 architecture a little bit. And this begins with the Intel 186 and up from there. The processors had a system put into them that handled any kind of invalid operations or illegal operands that were sent to the processor. And if there was an illegal operation of sorts, the processor would then throw an exception, and in Intel's vernacular that was represented as #UD, so that's how they identified the exception. And then that would be captured by the operating system's crash handler and basically terminate the program so that it would not bring the whole system down from making it unstable and whatnot from the invalid operations. And you would have seen this in Windows back then for sure, and of course we still have various Windows crash screens today, but back then they would look something like this, and they would usually say something along the lines of, this program has performed an illegal operation and will now be shut down. So that is the CPU throwing the exception and the Windows crash handler taking care of that to close the offending program. So with the F00F bug, and this is going to delve a little bit into Intel assembly language, and I'll try not to get too much into it because trust me, it does give you a headache from me understanding that personally, trying to disassemble various programs to understand how they work. So the hex code for the F00F bug is represented as F00F C7C8. And this is a locked compare and exchange operation of 8 bits between the EDX and EAX memory registers. Now, this by itself is an illegal operation and is not allowed. It automatically, of course, will throw an exception. The problem is when the processor is trying to call the exception on there, the way that, of course, I should mention, the way that this compare and locked exchange works is that there's a locked memory read and a locked memory write operation that goes on here. But the issue is that when this code runs, it ends up doing the locked memory read twice, and a locked memory write never occurs. And basically, because this locked memory write never occurs, the Pentium pretty much just throws its hands up in the air, wondering where its locked memory write operation is, and just hangs itself, halting all activity on the processor and subsequently all activity on the computer. And there's no way to get out of this. The only way you can do it is with a hard reset of the machine. That's pushing the physical reset button or turning the power switch off and then back on. So now that we have an idea of what the F00F bug is and how it affects these Pentium processors, why not look at them on a couple of different Pentium systems here. Let's clear the screensaver. So this is a Packard Bell Legend 409 CDT I have. This has a socket 5 Pentium processor, 75 megahertz, and we will run the F00F bug on here. Now, you actually saw this at the very beginning of the video, and I actually set it up to masquerade kind of as a malicious program because this is one of the things about the F00F bug that concerned a lot of people, is that it was a simple one line of code that could be inserted into any assembly program and then sent to someone, and then it would just bring down the whole system when it got to that point in the code. So this is the F00F bug program that all it is just a single line of code. And as you saw in the demo, well, let me bring it up here, bring up Windows. I usually like to have music or something playing with it because that way you can see what's going on with the system. Let me bring the camera over here as well. So I've got the face of the Legend being shown here so we can see the hard drive activity light. So we'll just play Beethoven's Fifth Symphony once again. That load up. The system is definitely not a speed demon by any regard. Now we should have Beethoven playing over the speaker. And now we will go ahead and halt the processor with the FOOF bug running this program that I called Click Me. Takes a while to load. Oh, and it's stuck. Yep, so there's again nothing happening on the screen. I'm looking at the keyboard. We can look at things like our keyboard light. I can't take it off of numlock. Can't do text lock. Pressing Control Alt Delete. Of course, moving the mouse here is not doing anything. So my only choice is hard reset. So that's the FOOF bug being demonstrated on a socket 5 Pentium. Now let's try another desktop with a different Pentium processor. So here is another Packard Bell computer. This is a Platinum 2220, and this has a socket 7 200 megahertz Pentium with MMX technology. So I'll go ahead and open up my computer. And let's do the same thing as before and just give a little bit of music just to have something audible to hear when the computer fails. So how about this time? Oh, let's use the good old Canyon MIDI. Canyon MIDI. There we go. Now I got a Canyon MIDI music. Now, since I have the FOOF bug on a floppy disk I use for bug testing, we're going to read it from a floppy disk this time. And of course you can see some of the other bugs I have on this disk for testing. There it is, FOOF C7C8. Let's go ahead and run it. And whoops. Computer is locked up, our notes are stuck. You can see our floppy drive light here is stuck on solid. It's not turning off. We run back over to our keyboard, we could still not turn off any of our keyboard keys or get any kind of mouse activity going on. We have to go all the way back and hard reset. So that was the socket 7 version of a Pentium processor with MMX that was affected. Let's look at another computer. So here is a Packard Bell Legend 100 CD. Yes, I have a number of Packard Bell PCs. This has a socket 4 Pentium 60 megahertz processor in it, and it is one of the FDIV Bug processors, which is the computer I use to do my video on it for TikTok and another channel. So I will take my bug disk and put it in here. We're running MS-DOS 6.2, so we're not going to show it in Windows. We're actually going to show it in real mode DOS here. So let me go ahead and switch over to the floppy. Change to our directory containing the FOOF bug. And we'll go ahead and run that. C7C8. Press enter. It tries to execute it. And just like with the Platinum, we can see that our 3.5 floppy disk drive light is stuck on. I'm pressing buttons over here on the keyboard. Numlock not coming up. Control Alt Delete not doing anything. All we've got is just a blinking cursor in DOS there, and nothing again is continuing to happen on the system until I come over here and press the hard reset button. So hey, that's the desktop Pentiums, but I can hear you saying, what about the mobile versions of the Pentium? Okay, let's look at one of those. Here is a Toshiba Satellite 315 CDS laptop. This has a mobile Pentium 200 megahertz processor with MMX technology. So we're back in Windows on this. Let's go ahead and give it a little bit of music with the Passport MIDI file. And let's go and run our program from our floppy disk just like before. We run it, and Windows locks up solid. And our floppy disk is still turning away with its light stuck on, as we can see from its indicators. And press keys on either one of them, and Alt-8 still doesn't work. So on the laptop here, I either need to use a little reset pin, or I need to come over here and force it off. Just like so. So, okay, we've pretty much seen it on desktops and laptops, so the question is now, what happens if we try to run the FOOF bug on a more modern processor that's actually been corrected for it? So now we have this Toshiba 2595 CDT satellite laptop. Now this has got a 400 megahertz Celeron processor in it with its corresponding chipset. We've got Windows 98 2nd Edition loaded on this, and I've got my bug testing disk loaded into its floppy drive. And if we try to run this now, you notice our computer is not locked up, and the system has caught the exception from the invalid operation, as it says here, trying to be caused by the invalid instruction. So, this program has performed an illegal operation and will be terminated. This is what I explained earlier. That's how the exception handling for a processor is supposed to work, especially in the Windows operating system. We click OK. The program closes out, and our system stays nice and responsive, and we can go about our business. So, this is how the exception handling was supposed to work. But because of that flaw in the first generation Pentium, this exception handling does not get caught, and we end up having a halted or hung up processor, rendering the whole system stuck until we hard reset it. So there you pretty much have it in a nutshell, Intel's FOOF bug. Hey guys, Brian here. Do me a favor and click that like button down below, and while you're at it, go ahead and click the subscribe button and hit that notification bell so you don't miss out on any new content when I post it. See you guys in the next one.